Right, so while IntelliJ is installing, we'll go ahead and get started on this. This is probably going to be the one of the longer lectures of this class because we will do very little lecturing in this class. This class is my favorite class to teach, and I have fine-tuned it to be as good of an experience as possible for basically every student. Now, that being said, this class does rely, your success on this class does rely on you showing up and actually attending class. And later on in the semester, as the semester goes by, I have noticed over the past couple years that, you know, it's kind of natural that a number of students stop showing up. I would just suggest that if you are not committed to coming to every class, right, then you might be better off dropping this class so that to make room for the people who very much want to be in this section, because I do make it a very strong objective of mine that I work with every student in here, and if you are not able to show up, then that does kind of become an issue. That being said, you know, things do happen. So I'm not necessarily, I don't take attendance, I'm not a stickler for it. I'm just saying that, like, if you are in here because you think I'm an easy grader, that's not necessarily the case for this class. I'm just, the material I have is very good for this. So, all right. So this is 2168. This is data structures. So there's basically in every computer science degree, there's a certain number of core courses you got to take, and this is still part of this main branch of material that's spread along anywhere between 3 and 5 courses, depending on the curriculum of the university. At our university, it used to be 3. Now, it's currently 4 core courses, which is your Intro to Programming, your Object-Oriented Programming, Data Structures is number 3 for IST majors, and data science majors with a concentration in bioinformatics. That's all you need. If you're computer science or in data science, then you take a 4th one, which is algorithms. This is also the course that where at least last I checked, the companies like Google and Microsoft and Apple like to draw their material from for their interviews, right? So this is where basically we really start to do this stuff, and this is definitely the point at which I would say once you're done with this class, yes, you are definitely prepared for a co-op. You were probably prepared already and just have a large field to compete against, but here for an internship or a co-op, once you're done with this course, yes, I would be more confident in your abilities to do that because this is a lot of the stuff that you need. This course is a flipped course. So the way this is going to work every week is that you will have videos to watch. I made the videos myself. I'll go into more detail about that, but I have a promise for you. It's less than 2 hours of video watching every week. In return for doing that, most of the time, basically almost all the time in class is going to be dedicated to working on your homeworks in here. So a lot of time where you would normally be spending stuck on your homeworks, you're going to spend them in here and getting unstuck while I'm available. The entire idea of a flipped classroom is rather than having a sage on the stage, as they say, you have a guide on the side. So I will be. I'll go into more detail about how that works in a few minutes. You'll also get a number of assignments, about one a week. A few of them are 2-week assignments, and let's see. And then you'll also have 2 exams. So first off, let's just take a look at the Canvas website. Okay. Canvas website, we've got the start here to get you to go. All the recordings I do will be all the recordings for in class, that like this thing right here that you may be watching later on, are going to be stored here under this button, lecture recordings, which can also be found over here under lecture recordings over here. So click on this, and what this will bring up is what looks like a single video, but each of these videos is actually a embedded playlist. So, so you'll be able to see the current semester as well as all previous semesters that I've taught this course. So if you need the material and explained in some way, it's all there. All of the previous semesters I've taught the course, because why get rid of them when they're perfectly available? The guide for week to week can be basically found under modules. So start here, meet the professors. Meet the professor, that will give you information about me. Crash course data structure. So this is a 10-minute video done by the YouTube channel Crash Course. Okay, and it is basically a nice 10-minute summary of all the things we're going to be doing in this course. Well, a lot of the things we're going to be doing in the course. If you have not installed Java on your computer, or you need a refresher on how to do it, then I have a video over here. The URL I use is different, but I've updated the URL over here to Adoptium. So that will do the same thing and show you how to install it. And then here's how to install IntelliJ, which is what I'm currently using. And then, let's see. So now, naturally, because it's the first week of class, you didn't necessarily know you had to watch videos before you came to class. So don't worry about that, because the first thing this first week is review of last semester's material. That is the objective of this first week, reminding you what these things are. And it's a good idea of how it's a good example of the breakdown of how these things work. You have a video, you have a quiz, and then you have these. Then you have the assignment. I say quiz because there's no better word for them, but they are a minor portion of your grade, and there's no reason not to get 100% on them because they're online, they're unproctored, and you can take them as many times as you want. So you watch the videos, then you take the quiz. The quiz does have a 15-minute lockout between each attempt. So enough to be annoying, and to be a quote-unquote punishment for not getting 100%, but not slow enough that you can spam the answer. Sorry, not slow enough that it becomes an ordeal to retake it, and not quick enough that you can just spam the answers, right? So, so you watch the videos, you check your understanding through the quiz, then you are prepared to work on the assignment here. So you'll be able to find the videos for the week over here under basically, the videos for that. And again, those will be an embedded playlist. Over here, top, and you can see here it's broken up into multiple videos. So there are actually guidelines on how to do videos and stuff like this. These guidelines basically suggest 1 minute per grade level for the target audience. So I target around 12 to 15 minutes. Sometimes I am slightly above that. Sometimes I'm slightly below that. I just kind of fall to where the natural breaks in these sequence are. You'll see but every week we start out with a high-level overview of the material. I'll mute this. Now these high-level overviews were created by with me in partnership with the Office of Digital Learning for the Graduate 5016 class. But I created them with the intent of using them in here too, because we have a huge overlap of that same material. But as you can see here, we've got a 2-minute video, we've got a 12-minute video, 10-minute video. So it's easy for you to basically say, okay, I'm going to watch this video, then I'm going to take a small break. Video, small break. Or, so however you need to best work on them for yourself. So let's go ahead and, so now that you know that works, let's just go over the syllabus to kind of give you a better breakdown of this stuff and to go over some kind of class policies. So here are the things we will be learning besides the review of object-oriented programming. We'll be going over generics generics, reviewing inheritance. Generics are a feature in Java and a lot of other programming languages that I personally believe we should be using, because otherwise you get very confused as to why what you're using is different than what is actually gets used in Java. We'll be hitting array lists, time complexity, and linked lists. Once we get to linked lists, this will be the bulk of the first exam, which will be week 6. This being week 1. Then stacks, queues, recursion, trees. Trees will be the heaps, Huffman trees, sorting algorithms, and hash table. This will be the bulk of the second exam, which is week 11. Especially trees and recursion. That's the main focus on that kind of stuff. Graphs will be the last bit, as well as actually graphs and sorting algorithms will be the last bit. And then the final exam will be cumulative. So we have 2 exams in the final. Okay. Time and place, you found it. Congrats. I just need to update the section number. Our lab TA, I believe she will be attending on Thursday, so she will be here on Thursday. So that will be great, because I'll have an additional person here. You need a C better in 1166 and 1068. If you got a C in 1068, you may not be prepared for this course, and I might strongly reconsider taking 1068. A reliable laptop is strongly recommended, because you need it, because that's what we're going to be working on. We're going to be doing a lot of work with laptop. If you need to, there are kiosks where you can borrow a laptop for 4 hours, so more than enough time for this class. But if you do not have a laptop, talk to me. We'll figure something out. I have a number of laptops in my room, 2. That's a small number that I can hand out to students for emergencies and stuff like that. But that's basically my personal supply of recycled stuff, courtesy of my former TA David. So, but importantly, if you need to buy a laptop, please let me know. I can help you find one for $450 to $500 that will be reliable. And I want to emphasize that if your laptop is missing number of keys, or you have to copy and paste the letter T in order to type that letter, you're going to suffer in this class. And I mean that. Physically, emotionally, academically, suffer, wailing, gnashing of teeth, whatever biblical terms you want to use. You're not going to have a fun time if your laptop's basically hanging on by a thread. Please talk to me. We will find something that works, whatever that budget is, including the budget of 0. So, all right. The textbook, Data Structures, Abstraction and Design Using Java. That's by 2 former professors, Kaufman and Wolfgang, 2 former professors here. I don't care what version you get. My material doesn't really matter. This really, Data Structures does not get updated in terms of what material needs to be taught very often. Okay? Office hours. My office hours are on the front page of Canvas. They'll be from basically 12:30 to 1:30, Tuesday, Thursday. And of course, if you need to meet with me a bit earlier on Tuesday and Thursday, I'll be available, because I'm on campus for my next class as well, which is at 2. So just let me know. If you cannot meet during any of these times, or need to meet with me at a different time, send me an email. We can meet over Zoom. I'd say Monday and Fridays and Wednesday mornings are basically the easiest times to meet with me, as well as Tuesday, Thursday evenings. I do meet on Sundays and as well. And Saturday evenings. I'm completely unavailable, though, from Friday evening to Saturday evening. Okay, so from sundown to sundown. Okay, there is free tutoring available for this class, peer tutoring. So take a use of that. And then we also do have a Discord for this class. You can find it on the front page over here. It is of all my classes, and I have a lot of students who have taken my classes before, and they hang around in the Discord, as well as a number of the former TAs. So, wasn't really very active last semester because I've been so busy, but I will try to be a lot more active this semester. All right. I do expect you to show up. You did sign up for a course, and you are ostensibly paying for this course, so it makes sense that you would show up for this course. However, I am not going to be explicitly taking your attendance. Attendance and grades are highly correlated with success in the class. Sorry, attendance are highly correlated with your grade, but I do understand that life just does happen. Just keep me in the loop, right? If you're, if like you overslept or just can't make it, it's okay. You can send me an email or explain next time you're in class. If you're going to be out for an extended period due to health issues, please let me know ASAP, right? That being said, if you are sick, do not, or suspect you're sick, don't come to class. Let me know you're sick. Catch up on this lecture later. I'd rather you stay home, feel better, and not get me and everybody else sick, right? Because I'm going to be getting in your face, essentially, or close to it, because I will be going around this class. So every year it feels like everything gets more and more stressful. Excuse me, I know exactly who this is. Okay. Every year seems to get more and more stressful, so it's very possible that you have issues. So if you have a significant stress or worry, changes in mood, problems eating or sleeping this semester, whether due to my class or any other class or whatever, in such a way that it's affecting you in this class, please feel free to reach out at any hour to me. I get at least one student a semester where this happens. If I do somehow manage to, out of 100 students, notice that you have gone missing when you have been attending regularly, I will track you down. I've done that before, but it does also mean that I have to unfortunately notice out of 100 students, which is a bit tricky. I have done that before, but please reach out to me first. It makes my job easier because, again, I have a lot of students I have to look out for. Everybody can benefit from some amount of support. I'm not a mental health professional, but I can listen and possibly recommend you to these things, to whatever resources you need. Furthermore, I can, the earlier you'll let me know that things are difficult, like food-wise or home-wise, the sooner that means I can come up with like a alternate plan for you to take, for deadlines and to take exams, earlier. I can't really do things to help you when we're 2 weeks from the semester ending, right? But if it's like before the first exam and things have gone completely sideways, then we've got a lot more flexibility. If you have a disability of some kind or a need for accommodations, go through DRS. Most accommodations, I've yet to find an unreasonable accommodation to make for this class, and a lot of them are met by simply the fact that I'll be recording. You are allowed to make your own recordings. However, Pennsylvania is a two-state consent state, so you do need to let me know. And also, school policy is you do have to ask me for permission. So it's both legal and policy-wise. Grading guarantees that if you get if your average is above a 90, 80, or 70, guaranteed you get A, B, C. Not A minus, B minus, or C minus, A, B, or C at 90, 80, or 70. Okay? I'll explain later into the semester, but minuses are used to curve up people who almost made it to the 90 range. So last semester, so what I do basically at the end of the semester is I look for gaps, and once I find a large enough gap, I draw a line that basically says, okay, here's the line between A's and B's. That's historically around 88. So A minus, so basically if you get a 90, it's an A or a 90 or above, it's an A, and then like 89.3 or 89.5, those are your A minus grades. So the minuses are bound up there. Generally speaking, if you're showing up to the class, you bomb all your exams, but you're trying really hard, I guarantee you a minimum D. F's are reserved for people who cheat and people who just don't do any effort. Okay. Your grades are weighted like this. Quizzes are worth 5%. Again, those quizzes are basically no reason not to get all the points on those. Your labs and assignments are the assignments we'll be doing in here around 30%, and then your exams are a nice hefty 20%, 20%, and 25%. It's always been the way this class is, a bit more exam heavy, unfortunately. So if you're unfamiliar, if you have not taken a course with me before, this is the way that your the turning in process for homework works. And if you've taken 1051 with me before, this is exactly the same process, which is that you will submit you have a two-step process. Submit it online on Canvas. That is when we count it as turned in. Okay? And then you demo it to me or the TA. You demo it to me in class, office hours, or during the lab. And that basically shows me that you did the work. You might answer some questions about it. But basically, you'll be showing me that your Java code works. Initially, I did this because running Java code is like downloading it, importing it into an IDE, making sure that all the packages match, because you might have a different folder structure. That's a pain in the butt, especially if you've made a minor error and decide to take it in anyway. A number of schools do have if it doesn't compile, you get a 0 policy. But I kind of just sidestep all those issues by making me show it to me on your computer. So we do accept your late work. So first, the quizzes, again, are low-stake, unproctored opportunities. They have a due date, can be started anytime prior to that due date. But those are soft due dates, as I like to say. This is when I'd like you have them done, but as long as they get done, you'll get credit. I'm not going to basically be checking whether or not it was done by the due date. Labs are fairly firm. We have a 5-point per day late penalty on late labs. And then we have a hard deadline for your exams, right? So if you have accommodations, just let me know. I do give a practice exam for each of those exams. So for exam 1 and exam 2, I have my own practice exam. And for the final exam, what we'll be doing is, rather than me giving you my own practice exam, I'll be stealing final exams from other universities and we'll be going over them. So let's see. And the other thing is that late assignments, they are capped at a loss of 50%. So you can turn at any point in the semester, if for some reason you skipped an assignment, you can turn it in for half credit. Okay. There is this caveat over here. You have 2 weeks after the due date to demo your lab, otherwise it comes to 0. Normally I waive this policy, but this is here for the end of the semester if a student comes in and tells me, oh, I turned in everything late. At that point, no, we're not demoing all your assignments at the end of the semester because that turns into a disaster. And the final straw was when I had a student who could not connect over the Zoom, tried to do it using his phone, and I got treated to his shirtless body while he pointed his phone at the computer screen. That was the final straw. Like I said, 1051 students are something else. So anyway, if you have issues with getting this in, look, as long as you're honest and open with me, I'm a very chill dude, okay? Academic honesty. So I have all these things over here. The main thing I have to say about AI is that if you rely on AI to do all your work, you're going to be utterly helpless during the exams. That being said, my policy on AI, I try to be very reasonable about it because it is a tool and I will be using it actually and giving you suggestions on how to use it. So basically, I have all these things in this list that I'll go over very briefly about what's reasonable reasonable activities for academic honesty in a class with other students, and what's unreasonable. If it's reasonable for doing with the student, it's reasonable to do with AI. If it's unreasonable to do with the student, it's unreasonable to do with AI. Make sense to everybody? Okay, so in other words, treat the AI as another student, and that helps you kind of figure out, is this a reasonable use for this class versus is it not a reasonable use for this class? So this is blatantly stolen from Harvard CS50 class. So what's reasonable? Communicating with your classmates about the assignment. Please do that. Discussing the course's material with others. Do that. Helping another classmate identify a bug, right? If you ask the person next to you, hey, do you know why my code isn't compiling? She can look at your code. Please do. Help each other out. The way to master material is by teaching other people, okay? Right? So please feel free to share your code, even on Discord. Like, hey, I don't know why this code isn't working, right? And you can post that on Discord, okay? Worst case scenario, if it was somehow inappropriate, I will delete it and say, hey, Just FYI, that was a bit too much. And I won't punish you. I'll just simply say, hey, that was just a bit too much. Post this relevant section instead. Okay? Incorporating a few lines that you find online. That's perfectly fine. Like saying, how do I write a for, finding a for loop that does exactly what you need to iterate over this particular object. Yeah, perfectly fine, because there's probably one very good canonical way to do it. Sending or showing code you've written to someone, possibly castmates, so they can help you fix a bug, right? Sharing a few lines of code online, like on Stack Overflow, right? Turning to the web or other instruction for basically other resources for solution to technical difficulties. But as long as you're not basically saying, hey, solve this entire problem for me. Putting stuff on the whiteboard or a whiteboard, right? Having a tutor. All these are good as long as somebody else isn't doing the work for you. Not reasonable. Finding somebody else's solution and using it, right? Asking a student who's already finished to see their code. So in general, when you're the one asking for help, you can show your code. But if you are being asked for help, you cannot show your code. Make sense? That's generally the easiest way to stay in for any coding class to stay in the appropriate use case. Decompiling, deobfuscating, or disassembling solutions to problem sets. Not really relevant for this one. Failing to cite any, where you got code if you got it from somewhere, if you're copying it from somewhere. Citing in this class is very, very, very easy. Just leave a comment and the URL if it was from somewhere, or if it was generated by AI, just simply put a comment saying, hey, this was AI generated, or whatnot. Finding code, and if you use AI too much, but you cited it, the worst I'll ever do is tell you, you need to go back and do this yourself. Okay? Now, I won't, as long as you're open with me, that's different. Finding code online that addresses a question on exam and failing to cite it would violate this policy. Finding code you might address a question and then blindly copying and pasting it in the hopes that it will work and it doesn't is a great way is one of the few ways to make me angry, because that can be very dangerous if you don't understand what you're doing, and like delete everything on your computer dangerous. So all right, paying somebody else to do your work. I think this is fairly straightforward as to everything else here. Disclaimer, right? I might have to update the syllabus due to changes, and then you, believe it or not, have rights as a student, such as the right not to take 3 final exams in one day. So if you want to review those rights, they're right over here. So, okay. Now with that being said, let's talk about the first assignment. So I'm going to go ahead and create a new project over here. Okay. Blah, blah, blah. And let's see. The first time we boot up IntelliJ is always a risk. See what I mean? Okay, there we go. Okay. So our first assignment is a grade assignment. I got a number of assignments. So no professor can create a true banger, as they call it, for every assignment, Instead, what I do is I rely on, and every year there's one panel where basically we submit our assignments. I haven't done this myself, but you submit assignments to it, and basically the best assignments get put on this page for others to use. And so I've taken a number of these from here. This does not mean they're hard. This means a lot of them are actually quite good and entertaining. So this first one is quite old, but it is still perfectly entertaining and good to use. So let's see, we're going to make sure that this is, I don't need any of that. I don't need any of this. I just want the okay, I just want this. So let's just go ahead and make sure this runs, right? I don't need the free trial or anything with this. It will downgrade to Community Edition once you're done with it, and I'll try to figure that out how to, because the only difference with IntelliJ with the Community Edition is like for web dev stuff and other stuff. For the basic Java programming, I don't need any of this. All right. So the first challenge we'll have today, first off, let's go ahead and I think, so if we need to do a number of things here. First off, this is why I need to remember to do these things beforehand. Okay. Sync with the OS in terms of the theme. Apply. Next, what we'll do is we need to adjust the UI, let's see, font size. I don't need to use a custom font, but color scheme. General appearance, change font wheel with mouse wheel in all editors, font, JetBrains, mono. We'll use, do we not have Cascadia code? Boo hiss. All right. Enable ligatures. Do you have ligatures on this one? Yes, you do. Okay, I'm happy with that then. And now we're going to bump up the settings to a nice big 26 so that we can see. Hopefully this is now visible to everybody, right? Everybody can now see this without straining their eyes? Great. Okay, so if you're so for our assignment today, this is your first step for this, and part of the reason we do this in class. Go to Fox and Rabbit, and you can follow along afterwards. I'm going to move quickly, and I'll be moving around the room afterwards to help you after I showed this. This is just an introduction. You go to your Fox and Rabbit assignment. There's two things here. First, there's a PDF describing what I'm about to talk to you about, and then we have the actual code itself, which is in hunt.zip. Okay? We're going to download this file. So here's how we're going to do this. I'm going to download this file, put it somewhere I can find it. I'm just dropping it on my desktop, and I'll delete it in a bit. Okay? I'm going to go to my desktop. I'm going to extract it. And there is now a folder with all of this code. Okay? Sorry, with a bunch of classes now. Right? Everybody see that we've got a bunch of classes here? What I'm going to do, the easiest way to get them into IntelliJ, right, is I created a new project. And what I'm going to, and think of basically each project as exactly that, a project, like the homework assignment that you're going to be working on. So I'm going to take these, and I'm going to select them all. Works the same way in Mac. Make sure you're working in the unzipped folder, although you can probably do it with the zip folder. But what you want to make sure you do is you take these, you drag them right into here, or you copy paste them into here. You can either do it by dragging them and dropping it right here into the SRC folder, right? The SRC folder, that's important, that stands for source. Or you can select them all, copy, select the SRC folder, and hit paste. And then if it's successful, you'll see them over here in the SRC folder, right? If you have trouble with this, and about a quarter to half of the students will, I am going to help you. So don't fret, don't panic, right? It's literally my job to confirm it works. And by the way, if you're using Eclipse, it works the exact same way. Okay, just drop it into the SRC folder. So what we're going to do here is now we can confirm it works by running one of the two programs that have a main function in them, Rabbit Hunt and Grader. We'll do Rabbit Hunt because that's the most evaluative. And basically, as long as we get a window popping up, congrats, it worked. And there it is. This may be, depending on your configuration, this may be initially blank, or you might get something like this at first. So that was partially blank, but we get this GUI here with a window and a bunch of other things, and it hits run, and this dot moves around, and if you hit reset, you can run it again. In fact, if we hit reset, it generates a random configuration. I can actually blow this up here and hit run again, and now we can actually see a bit, it expands nice and well. So what we've got here is a classic Java way of implementing a GUI. This way of doing this is called MVC, or Model View Control. It refers to basically three parts. I'm just kind of explaining this because, believe it or not, all you have to worry about is one file and one function in one file. Okay? Okay. So the way to do the control is probably the easiest to kind of explain. The control is this window and these buttons. The control basically are the things you can click, right, that do stuff. Okay, that's all control is. It interacts with what's called the model, which is the internal logic of the code. The advantage of this is that if you program it correctly and basically isolate the components of the program from each other, you can just simply run the program without the GUI, and that's what the graphics, and that's what the grader does. It runs 300 of these instances of these programs in rapid succession, and it doesn't pop it up at all to show you because it doesn't need to. Finally, the view is the window inside the window. It's the grid we see. It's basically showing you the representation of what's happening to the program. So the view and the view and the control are all programmed for you. So what are we looking at here? We are looking at a very basic game here. The red dot represents so this is basically a bounded forest, first off, okay? These green cross thingies are bushes. They block line of sight and movement. Our red dot is a fox, and our brown dot is a rabbit. The fox is quite hungry, and its job is to find and eat the rabbit, which it will do quite well. Okay? And we can see that here. The rabbit's job is to survive for 100 turns. It survived 11 turns this time. Not very good. Your objective is to program a much more effective survival strategy for the rabbit than what it currently has. Your grade is on this program is equal to the square root curve of your survival rate. So simply put, I heavily curve your survival rate. And then I add additional 20 points onto that, so it's at 120. Anyway, your grade is going to be the square root of your survival rate times 10. So, for instance, if you survived 64% of the time, square root of that is 8, multiplied by 10, 80 would be the effective grade. Make sense? This means that also that there's highly diminishing returns to basically once you get into the A range, right? Once you get to a 90% survival rate, it's making minor adjustments isn't going to improve your grade too much, okay? Then I add an additional 20 points to kind of give you an offset. So most students end up with 110 or 111 out of 120 for this assignment. It's the only assignment I have where you probably aren't going to earn full points. I say probably because there is one way to basically survive at 100%, and it involves cheating. And I honor it for the first student who shows it to me. So, okay. So, but it involves you understanding the code in a very different way. So anyway, let's take a look at that code. So, the only rule I have that even if you cheat, you cannot break, right, is you can only modify the rabbit class, okay? This is your code. This is what you modify. So let's take a look at our rabbit class to understand what's going on. Public class rabbit extends animal. That means a rabbit is an animal, and it can do anything an animal can do, such as it gets a row, column, it can select a random number, it can look in a direction, it can tell how far things are, and it can try to move in a direction. Okay, the rabbit gets a constructor to basically start out with stuff, and then it has the decide mood, which is where you're going to focus basically the vast majority of your work. In fact, we can get a 90% survival rate by just simply only working in this one and not adding any additional variables or stuff like that, and I highly recommend that. His strategy and why he gets caught so often is return random model.min direction to model.max direction. So in other words, he's moving randomly a lot. This is not a good strategy for survival for our poor rabbit. Okay? We can see that the stuff like bush is very basic. The main things you want to familiarize yourself with to help you out here, and I'll briefly go over, is model, because model has a ton of very nice functions in it for you to use, as well as a bit of information here. For instance, there's a bunch of static final variables here. to recap what that means, these are basically numbers like that are basically rebound as basically variable names. So we know that instead of having to remember that 0 is north and 4 is south, you can just simply say model.s to get south. Make sense? That way you don't have to remember. And then model.min direction to model.max direction to remember, because you don't have to remember you start at north and go to northwest, right? You can just simply do that. Do that. Okay. And it has a bunch of other functions here, one of which is the most important of which is the turn function, which I'll go over later, which given a direction gives you a different direction with a number of 45-degree turns as an offset. That sounds complicated. I assure you it's not. It's one of these, a common recurrence in this class is things are a lot easier than they seem at the first glance in this class. Things in this class will seem extremely complicated and overwhelming, but they all turn out to be a lot easier than they actually are. If you've taken 1051 with me and did the hurricane tracker, it's that. It's that sensation where it looks complicated, especially a few weeks out from success, but then it gets very interesting. Okay, so let's look at the Fox code. Now, the Fox code is useful to look at, but not necessarily useful to copy. The most common mistake I see for students who start out is that we grab the Fox code and will basically try to reverse engineer this code. There's a reason I'm spending a lot of your valuable time here talking to you about this, because I want to get you all up to speed and on the same page. So anyway, the Fox has a bunch of variables. You won't necessarily need these variables. In fact, my solution, which survives around 92% of the time and is basically 20 lines long, does not use these variables at all. Okay? Can see rabbit, have seen rabbit now, can see rabbit now. So have I seen the rabbit in the past? Can I see the rabbit? And then stuff to track the rabbit. Distance to the rabbit, direction to the rabbit, current direction. Okay? So animals will attempt to move using the decide move function. If the decide move function will return an integer. If there is an invalid number returned or an invalid direction, by default, the animal will just stay still rather than crashing the program. So if you try to move into a bush or into a wall because, or do something illegal, you can't. It will just simply say, I'm going to stay still by default. So we start off by saying, can I see the rabbit now is set to false. That's a good idea for the beginning of each turn. And then this line 40 here, is probably the only bit of useful code. Sorry, line 40 and 41 are probably the only bits of useful code I would copy from the Fox, which is for int I equals 0, model.min direction, I less than or equal to model.max direction. And you'll see this in my code quite a bit, where we actually have a less than or equal to symbol, as opposed to, these two things broken apart. This is a feature of fonts that is supported by a lot of editors these days, where basically it exploits the ligature functions in text. So basically, like having the F, the top part of an F kind of curve over an L in a lot of standard fonts, right? It exploits this to say, okay, we've got two letters together. We're going to replace it with a different glyph, and I find this a bit easier on my eyes to read. If you hate it, don't use it. And but I love it. So less than or equal to model. So the less than or equal to is important here. If you have like a 30% survival rate and your friend has a 60 or 90%, this may be why, because you forgot. Basically, you have this, and that leaves out an entire direction. All right. And then what it does is that we have this other function, this other line, which I say is important. If look I, so that being the current direction, is equal to the rabbit, then that means I looked in that direction, I found the rabbit. What I'm going to do is I'm going to update to say I can see the rabbit now. I have, in fact, seen the rabbit at some point. I'm going to say the direction to the rabbit is this I, and the distance is this other function I have access to, which tells me how far away something is in that, how far the nearest thing is in that direction is, be it a wall, a bush, or whatever. If I have seen the rabbit recently, not necessarily this time, right? If I have seen the rabbit, which just probably got set to true, or maybe it got set true to last turn, what I will do is if I'm expected to not be on top of where the rabbit is, then I subtract that distance to the rabbit and I return that direction that I want to move. Basically, I say the rabbit's that way, I'm going to head that way. Okay. Otherwise, if I somehow got to where the rabbit should be and I somehow lost track of him, then I am going to instead say I have not seen the rabbit, and I'm going to now basically choose a random direction to move. And then this block over here basically says, hey, if I'm moving randomly, instead what I'm going to do is I'm going to choose a direction, and then if I hit an obstacle here, basically I'm going to try to go. Here we see the model.turn, and this is very useful. This is also useful for your code over here, this kind of block, not necessarily the way the fox is doing it, which says, hey, if I can move in this direction, I do move in that direction. If I can move in model.turn current direction 1. So model.turn, the way this works is that it's given a direction and a number. That number is the number of 45-degree turns. So say this direction is north, okay? Model.turn 1 would give me northeast. Model.turn 2 would give me east. 4 would give me the complete opposite direction. So this way you don't have to say, okay, if the fox is to the north, then I want to go south. If the fox is to the east, I want to go west. You don't have to come up with 8 different statements for each direction. You only have to do one and use this model.turn. And it accepts both positive and negative numbers. And it handles the modular arithmetic for you if you need that. Okay? And if it can't move because it's hit a wall, then it goes in a random direction. Okay? So let's go ahead and see how that works in practice, right? So we could slow it down and see, but also we can actually see how this program works step by step by hitting the step button. So that yellow laser shooting out is the look function. So the rabbit moves, then the fox moves. Rabbit moves, fox moves. So it just saw the rabbit. The look function found it, and now it's headed towards it. So let's see. Step. It doesn't see the rabbit, but it did see last turn, so it's starting to head in that direction. So now I can hit run. It's doing the same thing. And so when it sees the rabbit again, it basically updates its direction, and that's how it knows to go in that direction. All right. So how to not die. Let's talk about that. Basically, we have 2 strategies that I see students kind of come up with that are successful. The first one is the one I use, and it's way more, and it's super easy in terms of the way in terms of implementation. Once we get a good handle on it, and that is exploit line of sight. Basically, this is an asynchronous game. Understanding that this is a game, not necessarily a life simulation, is key. Because basically I'll move and then the fox moves. The fox moves, and then he doesn't get to update his information until his next turn. So basically, if he moves into my line of sight, I can potentially see him and react to him before he even sees me, so I could scurry away from his line of sight. So if I just simply stay put and wait to see him, then I can move out of his line of sight, because the line of sight, if we just simply open up a whiteboard, do I not have that installed? Okay, paint. You're just gonna, right? Here is our fox, right? His line of sight is something like this. I don't have to draw all the directions, but, you know, here we go. But like this area over here, and here, and here, and here, those are all blind spots, right? It can only see in the straight lines. So, simply put, if I am over here, right? If the rabbit is over here, I could just simply say, move into this blind spot, and he would not see me, right? I wait for him, I see him, he hasn't seen me yet, so I move over to his blind spot. Okay, that's strategy number one. It's pretty good. And if you do it correctly, you can get a 90% survival rate or higher. Strategy number two, if you've played, which I don't recommend unless you have a lot of free time, is something called kiting, which if you've played an MMORPG, you may be familiar with this term. Kiting is basically where one player looks at the big scary monster and goes, look at me, chase me instead, and then he runs, while everybody else whittles him down with damage over time effects and basically you hit him with a poison arrow, and the person who's kiting, his job is basically to stay ahead of the monster while it simply expires. Here, this strategy is basically you just wait until 100 turns have passed, and then you automatically win. So this involves basically players trying to do like an infinite run around the bushes or something like that. I tried that initially for about 3 hours, and it could only get like a 40% survival rate. And then I changed over to the current strategy I use, and that's been a lot easier. So your goal, what I want you to try to do now, before we, in this half an hour we have, is I want you to try to implement over here, the decide move function over here, specifically to just first get priority one, get this running, okay? And that's where I definitely want you to help you be at. Priority two, look for the fox. Basically go around, make sure that your guy can shoot out laser eyes as well, right? To kind of see what's around him. And then priority three would be respond in some way, shape, or form. You see the fox, do this. Otherwise, stay put, right? Because if you move around, you give the fox a chance to see you, and that could be disadvantageous. Okay. Also, one last thing. To emphasize that I do want to participate with others in this class, this can be done as a pair programming exercise. A few of these can be done as a pair programming exercise. And what I mean by that, especially since it's the first week and not everybody may have a laptop, you can go and sit down next to one person. You can pair up with somebody else. You also do not have to do this. You can pair up with somebody else, and both of you can submit the same code and demo as a team, both receiving the same grade, submitting the same assignment. Make sense? So basically, you can work in a group of two, and I will basically check you both off. Just to emphasize that, again, this is the first week. All right, so with that, I'm going to make my way around the room, and if you are stuck on something such as importing all these things, I will help you, okay? Otherwise, if you have questions, let me know.